Myself, Mr. Jamuna Prasad Kundu, Assistant Professor, Department of Mechanical Engineering, Mollabhum Institute of Technology, Bishnupur, Bankura, West Bengal. Today's my topic is hydraulic turbine. Basically, I am going to introduce the PELTON turbine or PELTON wheel. Introduction. A water turbine is a rotary machine that converts kinetic energy and potential energy of water into mechanical work and rotates the shaft to produce electrical energy. Basic working principle. Hydraulic turbine converts the potential energy of water into mechanical work. Figure shows a layout of a hydroelectric power plant. A dam is constructed across a river to store water. Pipe of large diameter called penstock, which carry water under pressure from the storage reservoir to the turbines. These pipes are made of steel or reinforced concrete. Turbines having different types of vanes or blade are fitted to the wheels. Tail race, which is a channel which carries water away from the turbine after the water has worked on the turbine. The surface of water in the tail reservoir is also known as tail race. The difference between the head race level and tail race level when no water is flowing is known as gross head. It is denoted by H suffix G shown in figure. Neat head is defined as the head available at the inlet of the turbine when water is flowing from head race to the turbine. A loss of head due to friction between the water and penstock occurs. Though there are other losses also, such as loss due to bent pipe fitting, loss at the entry of the penstock, etc. Yet they are having small magnitude as compared to frictional loss. So the neat head is the difference between gross head and head loss due to friction. Head of the turbine indicate the specific energy of water and it is defined as the energy of water per unit weight. Nozzle are fitted at the end of the penstock which converts the pressure energy of water into kinetic energy. Next, classification. A hydraulic turbine are classified according to the type of energy available at the inlet of the turbine, direction of flow through the vane, head at the inlet of the turbine. Thus, the following are the important classification of the turbines. Based on head, high head turbine, PELTON turbine are used for high head and low discharge. Medium head turbine, Francis turbine are used for medium head and medium discharge. Low head turbine, Kaplan turbine are used for low head and high discharge. Next classification based on hydraulic action of water, that is impulse turbine, another is the reaction turbine. In impulse turbines, the energy available is only kinetic energy. The turbine as impulsive force is utilized. As the water flows over the moving vanes, the pressure is atmospheric from inlet to outlet of the turbine. Reaction turbine, the inlet of the turbine, the water pressure and kinetic energy are changing in reaction turbine. So when water is flowing in the runner, the pressure as well as the velocity more will be changes in case of reaction turbine. So another classification based on direction of flow of water in the runner, that is tangential flow turbine, radial flow turbine, another is equal to mixed flow turbine. Axial flow turbine, mixed flow turbine, radial flow turbine, tangential flow turbine. If the water flows along the tangent to the runner, the turbine is known as tangential flow turbine. If the water flows in the radial direction through the runner, this is called radial flow turbine. If the water flows from outwards to inwards radially, the turbine is known as inward radial flow turbine. On the other hand, if the water flows radially from inwards to outwards, the turbine is known as outward radial flow turbine. If the water flow through the runner along the direction parallel to the axis of the rotation of the runner, the turbine is known as axial flow turbine. If the water flows through the runner in the radial direction but leaves in the direction parallel to the axis of the rotation of the turbine is called mixed flow turbine. Next, three most popular turbines: Pelton wheel or Pelton turbine. It is used for high head low discharge impulse type tangential flow. Next is equal to Kaplan turbine. Kaplan turbine is axial flow reaction turbine, high discharge low head. Francis turbine also radial flow turbine, reaction type, medium discharge, medium head. Next, Pelton wheel. Pelton wheel is an impulse type water turbine. It was invented by Lazar Pelton in the year 1870. This turbine is used for high head. It is tangential flow impulse turbine. Next, specification. Specification for the Pelton turbine. Power generation is about 400 megawatt. The speed rotation range from 65 to 800 rpm. Efficiency is about 85%. The runner diameter is about 0.8 meter to 6 meter. Main components: nozzle and sphere, runner and bucket, casing and braking jet. Nozzle: it controls the amount of water striking the vanes of the runner. Casing: it is used to prevent splashing of water. Runner and bucket: it is circular discs on the periphery on which evenly spaced buckets are fixed. Braking jet: its function is to stop the turbine in a short time period. Next, Pelton turbine working. The flow of water is tangential to the runner, so it is a tangential flow impulse turbine. The runner consists of a single wheel mounted on a horizontal shaft. Water flows towards the turbine through a pipe called penstock and flow through the nozzle. The high-speed jet of water hits the bucket vanes on the wheel and causes the wheel to rotate. A spare rod which has a spare-shaped end can be moved by a hand wheel. This movement controls the flow of water leaving the nozzle before striking the bucket. The bucket or vanes is so shaped that when the water striking it gets split into two halves. Next, The velocity triangle of Pelton turbines. Alpha nozzle angle, theta vane angle at inlet, phi vane angle at outlet, beta angle between V2 and U2, V1 and V2 absolute velocity at inlet and outlet of water, VR1 and VR2 relative velocity at inlet and outlet respectively, VW1 and VW2 fuel velocity at inlet and outlet, VF1 and VF2 flow velocity at inlet and outlet, U and U2 blade or vane speed at inlet and outlet. So this is the velocity triangle. In case of Pelton turbine, the velocity triangle shape is shown. Next is equal to efficiency. Efficiency, hydraulic efficiency, mechanical efficiency, volumetric efficiency, and last one is the overall efficiency. Hydraulic efficiency, it is defined as the ratio of power given by water to the runner of a turbine to the power supplied by the water at the inlet of the turbine. Mechanical efficiency, the ratio of the power available at the shaft of the turbine to the power delivered to the runner is defined as the mechanical efficiency. Volumetric efficiency, the ratio of the volume of the water actually striking the runner to the volume of water supplied to the turbine is defined as the volumetric efficiency. Overall efficiency, it is defined as the ratio of water overall efficiency, it is defined as the ratio of power available at the shaft of the turbine to the power supplied by the water at the inlet of the turbine. Thank you.